So welcome back again. And as the rest continue joining, we can have a look at the exercise I gave you. And I think I wanted you to get me the pseudo code for the 1 to 2 Demux. So we can do it here. Who got it? Somebody can try before I do it.
For the decoder or for the encoder?
For the 1 to 2 Demux first, before the decoder.
And try.
Yes.
So if S is equal to 0, then I0 is equals to I.
Then
I0 is equals to
F0.
I mean F, sorry, F0 is equals to I.
Is equals to I.
And F1.
And F1
is equals to 1. I mean 0.
Is equals to 0.
Yes. Else F1 is equals to I.
Equals to I.
And F0 is equals to 0.
Yeah, that's perfect. I think that's quite okay. Because I thought maybe some of you might have forgotten the other F. Please know that the F0 is I, and then the F1 should be 0. So you need to include it. And also F1 is equals to I. The other F0 should be forced to 0. That's what you're supposed to do. And what do you think will be the code for this? The Arduino implementation? Somebody has to give us that implementation.
If S is equal to 0.
If S is equal to 0.
S is equal to 0.
Yes.
Digital right.
So digital right.
13. Is it 13 we're using again?
We will take 13 and 12. So 13 will be F1 and 12 is F0.
Oh. Okay, so 12, comma, I.
12, Okay, 12,
Yes.
comma I, that's okay.
Comma, I. Else. Else digital right 13.
No, we're not doing the else at this point.
Okay.
First of all, you need to do digital right
13,0.
12I. Then you also need to force the other input, which is 13. That is our F. That's F1 to 0.
Yeah.
So assume this is 13 and this is 12. Then 12 is I and then 13 is 0. So, and this should be done inside the brackets so that it works properly. So from there, I believe you can be able to see what's required. Then anybody else who can give us what comes next? What will be the next statement?
Else?
Yes.
Digital right 12,0.
Digital right. So I'll just pick these ones because you're going to repeat them. And I will have Did you write 12?
12, comma 0,
0, that's okay.
and 13i.
39. That's perfect. You guys, now we are getting what you are doing. This is what will happen. Please know that if it's data, it will go to 12. But now when you're using Arduino, if it's a 0, it puts off 13, it puts off 12, and also 13 will be off still. But the off that we have here is not data. The off that we have here is 0 data. But if you have a 1 for this, then this will be on. And this remains 0. Else, you interchange. That input goes through 13 this time. This time it was going through 12, this time it goes to 13. And I think we can be able to implement that shortly, maybe in the practical, hoping that we'll manage to get enough time to do that. But that's what we expected for the pseudocode for this one and also the program code. So next we look at the what did you get for the decoder, because we are doing the decoder. And it was a 2 to 4. We had a truth table, so what do you expect to have for the pseudocode? Check in your table. I hope you had to put it down somewhere. Remember when we had, in fact, just look at it this way. It's very easy to do an implementation, not even based on that table. Remember, we are changing our input binary to output decimal. So if you have our inputs, there are 2 of them. If you have I1 to be, both of them, if they are 0, then that's decimal 0, which means you're going to pick I0 to be active. The rest will actually be off. Else, you do the other combination. Where we have 0, 1, change it to decimal, then F1 will be activated, but the rest will be off. Then for 1, 0, F2 will be activated, the rest will be off because F2 is basically representing 2 decimal of 1, 0. And finally, you're going to have for 1, 1, input 1, I1 and I0 being 1, 1. Then the F3 will be activated because that will be giving us a decimal equivalent of 1, 1. And I hope you are getting that explanation. So if we put it in a pseudocode form, this is what we do. And I will have 2 inputs which are given by I1 and I0. Both of them are equal to 0. Then F0 will be active. And for it to be active, we say 1, which means if it was to put it on or off, it will actually be on. But the rest will be zeros. So F0 is 1. F1 F2 and F3 will be equal to 0. That's what you need to do. And you get your pseudocode for that. Can just put it that way so that we get enough space. But otherwise, else if we just copy the same and we will be changing the ones to be appearing at different points. So else if I1 is 0 and I0 is 1, which means this is 1, then activate F1. The rest are zeros. So change this to F1, and then this now becomes F0. F0, F2, F3 will be 0. Then you do an else if again. This is a bit complex, but not so much if you understand what you are doing, that you are changing from binary to decimal. Else if I1 is equals to 1, I0 is equal to 0. So which one do we force to? I think there's something here we are not doing right. So F0 is 1 for this. Then F1 is 1 for this. The rest are zeros. And this time we switch F. If you guys are still around,
F2.
it's F2.
Yes.
The other ones are not around. They have left. They went.
We're here.
Yes, sir.
Here.
Why are you not talking, you guys? You look like you are sleeping. It's not time for sleeping. I thought now that we have this, you must be sleeping 24 hours. So, which one do we put here?
F1.
F1. F1, F2, and F3 are 0. That's correct. Then, who gives
F0.
me the next statement then? Based on that, you can actually be able to tell what comes next.
Else
Else,
F3 is equal to 1.
yeah, that will not be correct. Let me, is it? Yeah, it's correct. Else, it's correct. Else, else F3 is equals to 1. The rest are zeros. And those will be F1, not F1. And you guys, you have mixed them. Anyway, this will be F1, F0, F2, F3 goes here. Then F2 comes here. Then here we are left with the F1 and F0. So we put F0 here. And you also put F1 here. And F3 will also be 0. And lastly, we are going to have F3, 1. Then we'll be left with F0, F1, and F2 being zeros. Now that's correct. And thank you for indicating that. Actually, it becomes very easy if you look at it. Yeah? You're just changing that truth table into set of code in that form. And I believe if we are doing the code, you also have it very easy. So if it's the actual code, then you are going to represent 2 inputs, which will be 2 switches at the input, and 4 outputs, which can have 4 LEDs at the output. Say that LED corresponding to F0 is activated when the 2 are 0, 0. 2 inputs are 0, 0. F1 is activated for 0, 1. F2 is activated for 1, 0, and F3 is activated for 1, 1. As simple as that. So that's the example I use for the decoder. I also use, for the decoder, we can use 4 to 2 and also maybe a 2 to 1. So let me just talk about the decoder. And I think I will leave these two I will leave this one. I will leave this one. Please do the code later. I believe you have seen what you have done for the pseudo code. You can actually manage to do the code, the actual code. And I have actually indicated what you're supposed to have, where it is, and the button switches. So let's look at the encoder. What does it do? At some point I had 32 guys, now I have 29. I hope the number is not reducing exponentially. By the time it gets to the end of the class, I have almost none. I might be doing the class myself.
We are here.
You are there, so please. Now that I've talked, somebody has come up. Now this guy is one. You guys, you are staying together, all of you, such that you tell the other friend, maybe just come on. This guy here is saying you are not present. There are some who are staying together, most probably. And you want, maybe you can even explain you want to save, so you are using one person. But you need to take care of corona. You know, social distancing is very important, my friends. Now,
Yeah, it is.
Currently, this is where now social distancing is very, very important. Currently, so take note of it and make sure you maximize on the save. And we hope that it does not get hold of anyone.
It won't. It won't.
Somebody can tell me what an encoder does. Just the opposite of the decoder, but exactly what is that supposed to be? It basically changes decimal
to human language.
No, human language is the decimal.
Binary.
It will change to binary.
Oh yeah. Sorry. Yes.
Yeah, it is the inverse of the other one. Please know that it basically changes our decimal to binary. So which means our human language to the machine language for the computer to be able to understand. And please note that the relation is given by n is equals to 2 power m, where n are the inputs and m are the outputs. So you can have a simple example of a 2 to 1 decoder, a 2 to 1 encoder, sorry. So I can actually draw it here. I forgot we have a rectangle. We can be able to use straight a rectangle. It makes our work very easy. I think I've been forgetting. And then we have some lines here. So 2 to 1, we will just have 2 inputs and 1 output. So that's our 1 output. And we can label them. This is I0, and the next one is I1. So we have I1, and our output will be given by F. So when this is active, what do you think will be F? When I0 is active, what's F?
Zero.
It will be 0 because we are changing that 0 to binary, which still remains the same. So you actually indicate that we have I1 and you also have I0 and I have just one F. So what happens when this is 0 and the other one is 1 because it will be active, then your F is 0 because we are changing that value to binary. When I1 is 1, then I0 is 0, we change that value to binary. That's the I1 we have here. And please note that that's what makes our encoder 2 to 1. Simple as that. And we are doing a 4 to 2, then it will be the inverse of what we talked about for the decoder. I hope I didn't deleted that. So maybe you can do that very fast. I want to do a 2 to, because a 4 to 2 can make it easier for us to understand what we are trying to deal with. So let me draw it also. And I can do it on this side. And this is a 4 to 2. So 1, 2, 3, 4. 2 outputs. What are they supposed to be? We have F0 and F1. This is F0. This is F1. And this will be I0 all the way to, so I0 all the way to I3. That's what we have for the 4 to 2. So we just simply call it 4 to 2 here. Encoder. The truth table will also be just something very easy that we need to interchange what we did for the decoder. So I'll have I3, I1, no, I2, I1, I0, then F1, F0. So interchange them. I will do for you the first one, then the next one somebody can do for us. This is 0, that is 0, that is 0 as well, and this is 1. So this should be 0 because we are changing 0 to binary, 0, 0. So what comes next?
0, 0, 1, 0.
0, 0, 1,
1, 0.
0. Output?
0, 1.
Output is 0, 1 because we are basically want to change this one to 1 because we are changing 1 to binary, so it will be 0, 1. Otherwise, the next one should be given by 0, 1, 0, 0, and then this should be 1. And finally, we have 1, and then this is 0, and this is 1, 1, because we are changing our decimal 3 to which is here to binary, which is 1, 1. That's how it works out. And, it's basically as simple as we have seen there. Though it can be complex depending on how you look at it, but personally, I believe it should be simple because you are changing the decimal equivalents here to binary equivalents here. You can also do the pseudocode for that, and also the program that I think you can do later. But in this class, maybe I'll give you some like 2 minutes for you guys to do for me the pseudocode for this, and also the program, because it is simpler. You can be able to do it. That's a 2-to-1 encoder. Then we can talk about where we apply those devices.
Is anyone here?
Yeah, we are there, and these guys are there, but they might be working. They should be working on their own now.
Oh.
Or you just joined. I think you are number 31. So you're wondering, guys are keeping quiet. Huh? We are here in the room.
I was there the whole time.
I'd given you an exercise, my friend. And the exercise we were supposed to do a pseudocode for this.
That is done.
And I'm actually now trying to do it for you. What do you think should be the next line? The first line is if I1 is 0 and I0 is 1, then F is equal to 0. Then what comes next?
Else I is equals to 1, I0 is equals to 0, then F is equals to 1.
Who is speaking? Aked.
Cynthia.
Cynthia, yeah. Because the microphone for Aked is also on. Cynthia, you said?
I1,
Cynthia.
I1 is equals to 0, then F is equals to 1.
So you do else, eh?
Yeah.
So you guys, please note that you cannot stop at else. And the reason being that these inputs have got 4 combinations, which will be 0, 0, 0, 1, 1, 0, 1, 1. So 0, 0 and 1, 1 are not taken care of. And therefore, you have to take care of them in the program. And how are you going to take care of them? You say else invalid. They don't exist. I hope somebody has gotten the explanation I've given you.
Yes.
Why we require those 3 lines? Because if you look at these inputs, we have taken care of 0, 1, 1, 0 combinations. What about our case where we have 0, 0 and our case where we have 1, 1? You say they don't exist because we are changing something to binary. You can have nothing to change to binary. You can also have, you need not to have many, or for this case, 2 inputs to change them to binary. You can only change 1 input to binary. You can't change 2 of them. In fact, there are cases where you might get 2 inputs active, because if somebody presses like a keyboard is a very good encoder. If you press 2 keys at the same time, what usually happens? If it happens that you press the keys at the same time, sometimes we use what we call a priority encoder. You prioritize. You can take one of the input to be higher priority. So if you take one of the input to be higher priority, then that's the one which will come out. And that's what we usually call a priority encoder. So priority encoder can be used in some cases to take care of those cases where you have 2 inputs active at the same time. And if they're active at the same time, then you need to give one a higher priority and the other one a lower priority. Like the keyboard and the mouse, you guys, you are aware that they have what you call hierarchies. In fact, most of the inputs usually have got hierarchies, so that you need to know if the 2 of them are activated at one time, the one with the higher priority is what will give us an output. So how do you use the encoder and the decoders? Where do you apply them?
In communication?
Yeah, they are used everywhere.
Yes,
All the
everywhere.
digital systems will require to use encoders and decoders. And how? Because you have to convert everything to binary for the computer to understand, and you have to convert everything to decimal for us to understand. And please note that it's not only decimal. Usually, you have your decimal values here. We know them as 3, 2, 1, and 0. But these 3, 2, 1, and 0 represent IDs for some devices, for some programs, for some values, for some letters. Like now, these ones are letters that we have here. So please note that it's not ending at the decimal values we have here. It will again go to a higher level, and the higher level is representing something in its real form. Like now, you can have a number of students in my class when you are like now 31 for today. You need to note that the computer is understanding you. Those names I'm seeing here one by one, the computer is giving you IDs, values, so that it can be able to display here. So inside that computer, your values are represented in binary form so that it can actually be able to process whatever you are processing with those values or those names, whatever you require. So encoder, decoder, they're very applicable in all the digital systems that we usually have. And I hope that makes sense with the members.
Yes, sir, it makes sense.
Any question regarding those devices? The decoder can also be used to in memory decoding. Usually you open a memory to take in data, addresses. Usually you can decode addresses for the computer to store data in those addresses. You need to give them values. So any question? Now,
I have a question.
I believe, okay, I'm done with the combinational logic circuits. The next topic will be on sequential logic circuits, which will be the last one. And I think that we'll do next week. But for now, I would want us to do as more practical. And I think we are going to use Tinkercad. This time we are not using Circuit Maker. We will be able to use Tinkercad. And I think we can implement one or two of those devices. We see the way they work. And that should happen in the next session that is coming after 2 minutes. Of course, this one is ending. So that session comes, we do something small up to that time. And then next week, I hope nobody's telling me that it's all day.
By the way, when are you having our exams?
Is it next week, part 1, I believe?
Not next week?
No, I don't think so.
This week is week 12. I think next week is week 13.
Yes.
Oh, okay.
So your exams are in week, the next week, part 1, eh?
Okay.
Yeah.
So next week we do a mock. I wish we could have gotten time to do it outside the regular time, that is on Friday, so that I can do a class on Friday to complete everything. So I don't know how your position is. I think we are trying to make up last time and we are not able to. So I'm not very sure what we will do. Because if we get enough all the time next week on Friday, we get the whole of that class, we complete the syllabus the way we are supposed to do, but I'm wondering how we will get maybe around 1 hour. I wish we could have gotten even 2 hours, 1 hour, 1.5 hours. We do a mock exam. Anyway, 1 hour is enough for a mock exam. So let's try to challenge it maybe after the break. You can discuss also. Then you'll be able to inform me how we can do that exam, mock exam, so that you understand what you're supposed to do in the final exam.
Sure.
So we meet after 5 minutes.
Okay.
Tinkercad, put it on.